Hi, this is Kumar Singh from Designed Analytics LLC, and you're watching another episode of Maverick Mondays. Well, since last few episodes, I have been trying to start this series of episodes on the brain-computer interface, right? But some other topic always came up at the last minute, and I decided to focus on that topic instead since last two episodes. But starting this episode, we will start that journey of exploring brain-computer interface, and specifically we will use the use case of smartphones, right? So there has been some talk about in the future the smartphones would be embedded in the human brain, right? So I thought maybe let's start with that use case to explore certain aspects, but at the center of it, in my opinion, was the utility. How useful is embedding the features of a smartphone in human brain will be, right? If you think from the perspective of a normal person, right, who is a person who does not have any form of disability, right, there are only certain situations in which they would like to use their brain signals to operate a smartphone, right? Those are very rare, and we will actually cover them in a separate episode of Maverick Mondays, right? But if you think in general, right, though we are getting lazier by the day, we are still not that lazy that we don't want to even lift a finger, just sit there and think in our minds, okay, call Susie, right? So the utility aspect in case of a perfectly healthy person of having a smartphone embedded in the brain is not that high, and the current hardware, the BCI hardware, is too clunky for that to happen, or a human to take that risk just for the thrill of it, right? So let's start exploring this use case of a smartphone from the perspective of a person who has some form of disability. They cannot speak, they have some form of paralysis that most of the parts in their body doesn't move. Maybe only the neck moves or the eyes movement can be captured, things like that. So in that case, right, there may be utility, right? If you think about having some form of brain-computer interface that allows them to leverage some smartphone functionalities like calling and texting, right? Now, one thing that you need to understand is that because the way these news articles are phrased, sometimes it may give us a notion of the BCI actually ends up giving someone speech, right? Saying that, hey, Neuralink allows a patient to say speak. In reality, we have to understand that it's actually not doing that. It's basically doing is it's mimicking the ability to speak. So I mean, after all, why do we speak? I hope most of us speak to actually communicate something, not just for the sake of speaking, right? So if in any way our thoughts in any form or any brain signal can be captured and transformed into speech, it kind of serves the purpose of speech, right? And that's what these brain-computer BCI interface solutions do. So this is a high-level architecture, right? But here is what happens, right? Through some form of, I would say, a type of electrode setup, which could be non-invasive, as in the electrodes are just touching your scalp. They could be semi-invasive, as in they have gone a little bit inside the scalp, or they could be intercortical, which is very invasive in perhaps in the case of patients who have a high degree of disability, right? Then these electrodes, this setup that the patient wears on their head, captures brain signals, right? These signals then are leveraged by an AI algorithm that translates, that decodes what these signals mean in terms of, it could be like interpreting the signals and associating it with a text, like, right, for example, the letter C or letter E, right, and then based on that decoding, a text is generated through brain signals. The brain signals, or in technical terminology, I think it's known as potentials, but eventually it's brain signals, right? So one thing you may have noticed, right, the focus in BCI, the reason it's not actually curing something in the patient is because it's mostly using the signal generated, and then it's done with the messing with the human brain. It doesn't do anything else, right? There are approaches, medical approaches, to stimulate the human brain itself, right, through electrodes and all, but this has nothing to do with it, and that's why it does not allow the patient to explain, but to speak, but it still allows the patient to speak in a way, right? So here is an example, right? Say a patient is disabled, right, but when they are looking at a virtual keyboard, they may actually kind of generate specific signals when they are looking at letter A, then a specific type of signals, and when they look at letter B, and these signals could be based on motor, right, motor cortex, as in they may end up making some kind of physical movement if any part of body allows. It could be speech cortex, but eventually the signal, right, generated for each of these letters, alphabets, words is specific, is decoded by the AI algorithm, a deep learning algorithm that understands, okay, when the signal pattern captured is in this specific way, it means this specific letter or word. It's simplified, it's highly simplified and narrowed down to one specific uses, but that's how it works, right? And then that text obviously can be turned to speech using AI again. So that's how the patient gets the ability to speak. As you can imagine, this kind of setup already exists for disabled patients, right? So extrapolating or expanding that to something like this is not difficult, as in allowing the patient to have the capability to call someone, to text someone is not that difficult if they already have some form of BCI setup in place. What you need is a tablet or a visual monitor that is powered by a AI copilot. Now this AI copilot is focused on helping, is more like a customized pilot designed around that particular patient's specific signals, right, specific behavior, and that's where it kind of transcends beyond the brain signals, the brain potentials that are being captured, and into some other aspects of behavior as well that AI copilot can be trained over a period of time. And as you can see here, it's not then difficult because the technology already exists for a person to say the text that, and the AI copilot knows that the text that they need to type is C and Susie and V, right? So when it's a combination of these, that means call Susie, a video call, right? That's just a made up example. The same way they can text anyone, right? So the hardware for that already exists. Most of these patients, if you see, they have this whatever chairs that they have, the setup they have monitors. What is needed is basically a AI copilot solution in there that is integrated with the BCI module, right? So that is the setup when the patient has some form of disability. Now in the next episode, we are going to transcend this with this background into how those who do not have this disability or any form of disability can actually have that kind of futuristic setup using the current technologies. And then we will also discuss about the future of this, right, based on where we are right now and where we are going, right? But what you can see before I conclude this episode is that for a person who does not have disability, the current hardware limitations should be obvious to you, right? These electrodes that touch the scalp are non-invasive, but the setup is elaborate. You wouldn't want to move around in that, right? If you do not have to. So the limitation in terms of having this kind of setup for those who do not have any form of disability currently actually lies on the hardware side, right? But if you still really want to have that smartphone capability where you actually do not want to speak or type anything, right, and yet want to actually end up like calling someone, right, just an example, then there is still a way using a combination of some of the other gadgets that we normally use in our day-to-day life and something that we are still not using as a day-to-day gadget, but is kind of a technical reality, and augmented reality glass, right? Specs. So yeah, that is the topic that we are going to explore in the next episode. Okay. I hope you liked the episode. I'll see you again with another video series tomorrow. Thanks for watching.